All right, this is a solution to problem number 7 from section 7.7, where we're asked to use the midpoint and trapezoid rules to get approximations, and then for each one calculate error. In this case, we can only calculate error because we know the exact value, and in this problem you'll notice they gave us the exact value, even though this would not be a hard integral to do. And again, the reason that they're asking us to calculate these errors is so that we can see how the errors behave as the number of subintervals increases. Generally, we won't know the exact answer when we're trying to estimate an integral, because if you know the exact answer, then why would you be estimating it? Okay, so this does ask us to do the rules with 4 subdivisions, 8, 16, and 32. I strongly recommend not doing 16 and 32 by hand. If you just simply Google midpoint rule calculator or trapezoid rule calculator, you'll find that website I showed you in class, and you can get the answer to the questions for that. But please make sure you can do the calculation by hand for at least for 4 rectangles, or 4 subdivisions. That's not very hard. So the integral here is from 1 to 9, and so I've included here a picture that starts with 1 and ends at 9. 9 is here. And so first we're using 4 subdivisions, so I needed to break this this figure up into 4 strips, because the total width is 8. That means each strip will be 2 units wide. So that means at 7 and 5 and 3, I'll have vertical strips drawn. So that breaks my region up into 4 strips. And now, depending on whether I'm using midpoints or trapezoids, I can place dots and just make my measurements. So I'll do this in different color ink, so I can try to keep it straight without having to clutter up the picture too much. For the midpoint rule, I want the top of a rectangle to hit the curve in the center. And so I'm going to try to draw a dot at the center of each strip on the curve. And when I do that, those dots' x-coordinates are going to fall above 2, 4, 6, and 8. So the height of the first rectangle is just the y-coordinate of the curve above x equals 2. The second rectangle's height is the y-coordinate of the curve above x equals 4, and so on. So my M4 approximation is going to be base times height for each of those 4 rectangles. The base is 2 each time, and the first height is f of 2. The second height is f of 4. The third height is f of 6. And the fourth height is f of 8. Notice that by multiplying 2 times that quantity, that is effectively multiplying 2 times this height, 2 times this height, 2 times this height, and so on. So I'm doing a little simplification of the formula so that I don't have to write base times each height. I can just write base times the sum of the heights, and it's the same thing by the distributive property. When you do that, I did it over here, I got 1,920. And so that's what goes into this box right here. The absolute error, because they told us that the actual value of this integral is 1,944, then I can also calculate the error as just the absolute value of the difference between 1920 and 1944, and that's just 24. So the number 24 goes in the box about the error. All right, so now let's look at the trapezoid rule. The trapezoid rule will use the same 4 strips, but now my dots are at the locations of where those strips hit the axes, so on the left and right side, and I'm drawing straight lines connecting those dots. So the red dots are all connected by straight line segments, and that gives me 4 trapezoids. The region that's within the strip and under the straight line top is a trapezoid. So T4 will be the area of a trapezoid is the base times the average height. And so again, instead of doing those separately, I'll just do base times, and I'll just add up the average heights. So the first height is f of 1 plus f of 3 over 2. That's the average of this height and this height. That height is the y-coordinate above 1. That's the y-coordinate above 3. So those are the heights of those 2 points, and I'm just going to add them up and divide them by 2. Let me just put a bracket in here. The second trapezoid has an average height given by f of 3 plus f of 5 over 2. And I'll just say and so on. So there's 4 of those that I have to do. And the formula that they give in the book is just based on taking this formula and noticing that here you have f of 3 over 2 and here you have f of 3 over 2, so you could add those together. So the formula that you normally see for this just collapses all of those, all of these different individual fractions and gives you one sum. So I'll have f of 1 over 2, I'll have that just once. Then I'll have f of 3 over 2 twice, and so that's f of 3. I'll have f of 5 over 2 twice. I'll have f of 7 over 2 twice. And I'll have the f of 9, the very rightmost point, I'll only have that over 2 once. So this is the formula that you'll see written in the book, and all it is a simplification of the one above it. And if you do that, you get 1,992 will be the answer that goes here. 1,992. And then if you see how much that differs from the exact value, remember the exact value is 1,944, that differs by 48. So that's the answer there. And just notice that the error, the absolute error for the trapezoid is twice the absolute error for the midpoint. That's what our error-bound formulas keep telling us, is that the midpoint rule has half as much error as the trapezoid rule. So that's how you would calculate M4 and T4. I strongly recommend doing that based on the pictures, but and then you can, if you want, do the ones for 8 subintervals. That's not too bad, but I definitely recommend you don't try to do the calculation for 16 and 32 subintervals. As I said, just look up a midpoint rule calculator or a trapezoid rule calculator to do those calculations for you. And if you have done the other problems, you may want to check. These are the, if you want to see if you're doing them correctly. For this particular problem, these are the answers to the other parts. Notice that every time the number of subintervals goes up, so we go from 4 to 8, 16, that the errors go down by a factor of 4. So we have a fourth as much error each time. This for both of these. We have a 1/4 as much error each time that we make the number of subintervals go up by a factor of 2.